Welcome to this module on direct and explorative use of point clouds. During this movie, I like to discuss with you the potential of point cloud data, how we currently often model the world, and how this can change if we would use point clouds directly. It is often the case that technology shapes our society. 15 years ago, it was difficult to imagine that nearly everyone would be carrying a mobile phone nowadays. However, the iPhone came along, and now you can probably not think of finding your way to the nearest restaurant without it. The same thing is happening with point clouds. A point cloud is a large and structured set of points in 3D space. Depending on what acquisition technique is used, different additional attributes are collected, such as color or the intensity of the return signal. Furthermore, a phone can also help you collect a point cloud. So similar to self-driving cars, is becoming a point cloud sensor. One of the point cloud datasets that is collected by means of aerial laser scanning in the Netherlands is the actual height model. As you may know, having insight in the height of the land in the Netherlands is quite important. For example, in the context of sea level rise. Are we still safe? Therefore, this height model is collected for the whole of the country. The measurement campaign leads to a huge amount of points. 640 billion, which are very close to the actual objects in reality. The data produced is split in two classes, ground and others, and the data is made available to everyone for download, for free, as open data. So if you combine this height model, together with the vector base map which the Dutch Topographic Service maintains, you can automatically make a 3D model of the whole country. However, this integration takes a lot of time, even if you use some supercomputing powers. And also, the resulting level of detail is rather limited. For example, as you can see, no roof shapes are present, nor vegetation is depicted. So point cloud data have a lot of potential in their raw form. Many expert users might be willing to use the original measured data. But what you then need is visualization and analysis tools that can be used for this purpose. In a way, this quote of Rodney Brooks sums it all up. The world is its own best model. It is always up to date, and every detail is there that you want to know. So if we want to make a model of reality, we need to sense it appropriately and often enough. And this is exactly what is happening, given the technological advances around point cloud collection. Very accurate representations can be obtained very fast. So you could state that point clouds in their raw form have more value than the derived traditional maps and models that we derive from them. We describe what should be produced, which objects should be picked and represented from the real world in our model. Traditionally, this process of measuring was slow, manual, and took a lot of work. But more importantly, many details of reality were left out, and data was collected mainly for a single purpose. If you compare this with point clouds, data collection is fast and cheap, covers great extent, the resulting data can be used for many different purposes, and a high degree of automation is possible. So when the Science Museum had to close their shipping galleries collection, they decided to scan the whole collection before it was stored away. The original collection already had an enormous amount of detail, as the conservator mentions in this YouTube movie. Every time I walked through, I found something I had not seen before. Something you can also see here. You can see many details in the image. However, this is not a direct image of the venue, but an image of the laser-scanned point cloud. And if you watch the movie on YouTube, for which only 10% of the collected points were used, the movie is showing an enormous amount of detail. So this illustrates that point clouds in their raw form are useful. They keep the details, and the user, by just looking at them, can get information from them. Just by having access to the raw point data, they can directly be used for all kinds of applications. For many applications, the very first step often is exploration. Traveling through an unfamiliar area or dataset to learn about it. And today it is even very easy to create a point cloud yourself. For example, by flying a drone and using some photogrammetric software. And maybe in the possible near future, your new autonomous car with all its sensors will also produce point clouds. This way of thinking thus calls for point clouds as an authentic data source. Modeling from the points may become too expensive in terms of time or amount of processing needed. And what is noise for one application, for example making building models, is actually very useful for another, for example studying vegetation to find habitats of birds. The challenge we face if the raw point data becomes an authentic source is that traditional models become derivatives, computed on demand. However, this is challenging as point clouds become denser and denser and they have a higher frequency of updates. So instead of processing the data always through a modeling step and only then making it available for an application, we foresee that we make the raw point cloud data available once they are collected, for immediate and direct use in applications. In a way you could see this as a new paradigm, rich point cloud-based modeling, as also proposed by Nebiker. However, this switch in perspective leads to a variety of challenges on different aspects, such as visualization and dissemination, data fusion, adaptive object recognition, and analysis that are directly using point cloud, in turn leading to a variety of research questions. How do we cope with managing the large amounts of data? How can we provide interactive visualization tools? How can we provide analysis tools that are directly using the unstructured points? And what kind of exploratory data analysis tools should be available to extract more information from the point clouds? And this also calls for adding these tools in our geographic information systems toolboxes to be able to directly use point cloud data. Not only tools for measuring and analysis, but also tools and techniques for influencing how points are displayed. Some of these questions have been central in the eScience Point Cloud project, in which the Delft University, together with database vendors and end users, have investigated the direct use of point clouds. Within the project, for the very first time, a visualization of the complete AHN2 dataset was made, which comprised the complete dataset with all its 640 billion points. Next to giving a visualization and making exploration of this massive dataset possible, the interface also offers some tools, for example for measuring distances. Also, others have been actively researching visualizing point clouds. And also here you can see novel interaction techniques being developed and researched, directly using point clouds. To give a recap of what we presented in this movie, society is often shaped by technology, and one of these technologies is point clouds. We have argued that raw and rich point clouds have more value than their derived models. They keep the details, and the value can be revealed by the end user. One person's noise is another person's data. However, to make this vision reality, there is a need for both effective data management of point clouds, as well as visualization, analysis and interaction tools that allow direct and explorative use of the dense sets of points currently already available to us. Thank you for watching and good luck using point clouds in a direct and explorative way.